Question number 7. Find the local maximum and minimum of function using both the first derivative test and the second derivative test. So we're going to first do first derivative test. These are two different techniques of finding, and then we are going to do the second derivative test. Okay. For the first derivative, obviously we have to find the first derivative for the function. First derivative of this is negative 6x squared plus 6x. After finding the first derivative, the step is to find critical points. Critical points is first derivative equal to 0 or first derivative does not exist. Now here the first derivative is a polynomial which exists everywhere. Therefore, we don't have to worry about this. So we can just put the first derivative equal to 0. I can factor 6x, actually negative 6x out. I'll be left with x here and minus 1. So x is either 0 or x is equal to 1. These are my two critical points. Actually, for both the methods, first derivative and second derivative, this much has to be done. We need to find critical points from the first derivative. Now here I actually start the first derivative test. For the first derivative test, you need to make a sign chart for the first derivative. And what do you plot on them? The critical points. So critical points are 0 and 1. Once you plot the critical points, you see that it's divided the whole number line into 3 portions. I'm going to pick test point in each of them. Let's say before 0, negative 1. Between 0 and 1, I'll have to pick half. After 1, let's pick 2. Okay. And I want to find function's derivative at these points, the test points. So f prime of negative 1 is negative 6 times negative 1, negative 1 minus 1. So I don't really care about the value of this, but I know that this is going to be a negative number. So f prime is negative in this area. Then at half, negative. This is first derivative, okay? So I'm putting it here. Negative 6 times half minus 1. So you notice that this is negative times positive, negative times negative. The answer is going to be positive. So first derivative is positive here. Let's do the last one. F prime at last test point is 2. Negative 6 times 2 minus 1. This is negative. Everything else is positive. So completely this has to be a negative number. So we have negative. That means, what does it mean for function? F is decreasing before 0. F is increasing because first derivative is positive. That means F is increasing from 0 to 1. First derivative is negative. Therefore, F is decreasing from 1 onwards. So we can tell two things here. We can say F is increasing on interval 0 to 1. F is decreasing on negative infinity to 0 and 1 to infinity. Okay, that's about increasing, decreasing. But we can also tell about local max and minimum. What is the criteria? If f prime changes from negative to positive, you see it is going down and then it started to go up. It is changes from negative to positive. Then we say f has local minimum at x is equal to 0 because it's going down and then started to go up, right? And similarly, if f changes signs from positive to negative, that means it was going up and started to go down, there it will have local maximum. So f has local maximum at x is equal to 1. So that is the local max and minimum of f using this. If they ask you local max and minimum value, you can find that by putting local minimum value would be f of 0 and local maximum value would be equal to f of 1. So you just have to plug it in the function itself which was given. Okay, so this first method is called first derivative test to find local max and minimum. Now let's learn about the second derivative test. As I said earlier, for the second derivative test also, this part still has to be done. Okay, the until the find the critical points, all that still have to be done. So we found the first derivative, we put first derivative equal to 0, we found critical points. Now for the second derivative test, we need to find the second derivative. How do we find that? We have the first derivative differentiated one more time. You will get negative 12x plus 6. Now what you do is you put critical points in the second derivative. Let's do that. Second derivative of 0 would be negative 12 times 0 plus 6, which is 6 and it is positive. And second derivative at 1 is negative 12 times 1 plus 6, which is negative 6, which is negative. Now, what is the criteria? Second derivative test says if second derivative is positive, we have local minimum. If second derivative is negative, we have local maximum. The second derivative at 0 is positive, therefore we have f as local minimum at x is equal to 0. And because the second derivative of 1 is negative, f has local maximum at x is equal to 1. You guys notice that's the same result as we found in the first derivative. So results shouldn't change if your method is correct, right? It's just that these are two different methods. One method is called the first derivative test and the second method is called the second derivative test.